We're going to start lesson 4.4 today, in which we are going to use a different method other than the one that you used in lesson 4.3, where you were counting and counting how much do you have to rise and over how much do you have to run between any 2 points. So let's review here though. First of all, slope of a line can be determined using any 2 points on a line because it is a constant rate of change. In other words, we have this straight line that does not zigzag. There are not different rates of change. It's constant throughout, so you can pick any 2 points you want from that line and calculate the slope. So slope again is change in y, that's our rise, over change in x, which is our run. How much do you have to go up or down between the points? How much do you have to go over, left or right, between the points? Or here's what our slope formula is. Y sub 2 subtract y sub 1. Y sub 2 just meaning the y value from one of the 2 points. In this case, we'll call it the second point. Take away the y value from the other point. Y sub 1 we can call the first point. So we have 2 y values. We find their change by subtracting. And downstairs we have x sub 2 take away x sub 1. So the x value from the point we took the y value from first upstairs. We start with that one down. And we take away the other x value. So you can see over here I have written, just a way to show, it's just notation. X sub 1, y sub 1 means the x and the y value from your first point. X sub 2, y sub 2, the x and y value from your second point. Doesn't matter which one you call the first point or which one you call the second point, you will get the same results. So let's find the slope of a line that contains these 2 points. Ordered pair 5, -7, and ordered pair 6, -4. I've said here, let's just let that first ordered pair, 5, -7, be our x sub 1, y sub 1. And let's let our other ordered pair, 6, -4, be our other one, x sub 2, y sub 2. So we're going to substitute into our formula that we just wrote down up here. So our y sub 2 value is the -4. And we're going to subtract from that the y sub 1 value, which is -7. So the subtraction sign does not take the place of the negative on that 7. And then we go back and we subtract downstairs. We go back to our x sub 2, which is 6. Take away our x sub 1, which is 5. So we're going to calculate this now. We have, first of all, let's change our subtraction upstairs to add, and the opposite of -7 is +7. So we really have -4 plus 7, which is 3, and 6 take away 5, which is 1. We can simplify 3 over 1 to saying the slope of this line is +3. So if we were going to talk about the behavior of this line on a graph, we should expect that this line would be doing what? It has a positive slope, so as we go across the graph from left to right, this should be a line that is rising on a graph. So if we have a graph and we use the slope formula to calculate it, and we don't end up with, if we have this kind of a behavior, we don't end up with a positive slope, we probably use the slope formula incorrectly then. Okay, let's move on to our next one. Find the slope of a line that contains these 2 points. So again, it does not matter which one's called x sub 1, y sub 1, x sub 2, y sub 2. It just give them, their distinction. So we can, let's call this one, let's just be different this time. Let's call this one x sub 2, y sub 2. And this one, x sub 1, y sub 1. And if somebody's already worked ahead and they didn't do it that way, you should still get the same slope we do. So we're going to substitute into our formula m equals y sub 2. Our y sub 2 value is negative 2. So negative 2, subtract, it's always subtraction. Our y sub 1 value, which is 7. And then we're going to do our x's downstairs. We have to go back and start with our x sub 2 value and subtract the x sub 1 value, which actually in this case turns out to be the same thing. So we're subtracting a negative 2. Now what we'll do is change these to add the opposites, both of them. I think it'll be easier for us to work with them that way. So instead of subtract 7, we'll have add a negative 7. Instead of subtract negative 2, we'll have add a positive 2. So negative 2 plus negative 7 is negative 9. And negative 2 plus 2, that's 0. Can we divide by 0? We cannot. So we would say slope m is undefined. Our slope this time is undefined. It's not 0. Negative 9 divided by 0 is not 0. Can't divide by 0. Therefore, we have an undefined slope. What would the behavior of our line be this time? If it's undefined slope, we would have a vertical line. In other words, there would be no run, 0 downstairs. Okay, so here's using the slope formula without a graph, because we don't have the graph. We don't want to take the time to graph it and have to use the counting method, so we can use the slope formula. Okay, let's move on to the back side, where we have find slope of a linear relationship given a table of ordered pairs. Well, they've given us 4 ordered pairs here. We have negative 2, 3, 0, 0, 2, negative 3, 4, negative 6. So we really have 4 points here. We only need 2 points to determine the slope of a line. So we can pick any 2 of those ordered pairs and call them our x sub 1, y sub 1, x sub 2, y sub 2. So pick whichever ones you want. Doesn't matter. Let's just go with the first 2 in the table. Negative 2, 3. I'm going to let that be my x sub 1, y sub 1. And I think I'll work with 0, 0. 0 is always kind of friendly. X sub 2, y sub 2. So we have m equals 0, our y sub 2 value. Take away 3, our y sub 1 value. Over 0, our x sub 2 value. Take away negative 2, our x sub 1 value. Let's change to add the opposite downstairs. 0 take away 3 is negative 3, or in other words, it's 0 degrees outside. The temperature drops 3 degrees. It is now 3 below, negative 3. 0 plus 2, 2. This can be changed to a mixed number or a decimal, but when we are working with slope, what we're going to do is, if it can't be divided out into an integer value, we're going to leave it as a simplified fraction or improper fraction. This is an improper fraction. So what we're going to do is, only one of the numerator or the denominator are negative, so that makes the slope negative. We'll bring that negative sign out front, and we'll say we have a negative 3/2 slope. So the behavior of this line, if we did graph those 4 points, then draw a line through them, what should we expect? We should expect that the line would fall from left to right because of its negative slope. Okay, so in our next table that we're supposed to find the slope for this linear relationship, as we're looking at those, I've picked a couple of different options here. We could, remember, you can use any 2 points. So we really have several options here. So what I would like you to do is I would like you to, pick the one that you're going to, you know what, let's do it like this. Let's have the row closest to the windows. How about you guys do the first set, and all the rest of the room, those of you in the middle and closest to the door, you do the other one, okay? So go ahead and work at them, and then I'm going to do both of them for you, and we should all end up with the same answer. I should get the same answer twice, and whichever one you're working, you should still get the same answer I do. Okay, hoping you're done by now. I did it both ways. So for those of you do over by the window doing it, you should end up with 13 over 2. And just out of curiosity to see if it turned out like the other one that I did, if I do divide that out, I get 7.5, I get 7.5. But we're going to leave it as 13 halves, remember. Typically, that's the way we would leave it. When those of you that did it the other set of ordered pairs, you should have gotten the 7.5 over 1, which divides out to 7.5. But you know what? We're going to, instead of leaving it as 7.5, let's do this. Let's take upstairs times 2 to get rid of that decimal. If we take the upstairs times 2, we have to take the downstairs. 2 times 7.5, oh, that should be 6.5. Good catch, those of you who have been trying to, tell me that, but you couldn't talk to me. 6.5. So 6.5 times 2 is 13. 1 times 2 is 2. Same answer, okay? So 10 take away 3.5 is not 7.5, it's 6.5. So any way we do it, we should all get the same thing, because any two ordered pairs, deciding which one's x sub 1, y sub 1, x sub 2, y sub 2, does not matter. It should all turn out the same. They're all from the same line with the constant rate of change. Okay, let's go to the middle of page 256 in your books. You should have already done this in your SQ3Rs. We're doing check it out problem number 3. Make sure you did this right. So on page 256, check it out problem number 3. The graph shows the height of a plant over a period of days. Find the slope of the line. Then tell what the slope represents. Well, on that graph, time is our x value, height is our y value, and they identify 2 of the ordered pairs on there for us. They say, okay, these 2 points, here's their names. So let's just work with those points. We have ordered pair 50, 20. So 50 days, the plant was 20 centimeters high in height, and 30, 10. After 30 days, it was 10 centimeters in height. Okay, so let's do our slope formula. Let's make this x sub 1, y sub 1, x sub 2, y sub 2. So m equals 10, take away 20, 30, take away 50. Take away 20, negative 10. 30 take away 50, negative 20. Negative divided by a negative is a positive, so it's going to be a positive slope. 10 divided by 20 is a decimal, so let's leave it as a simplified fraction. 10 over 20 can be simplified to 1/2. So this is a slope of 1/2. So this is really, remember, slope is like rate of change. So if x is remember, if x is representing the number of days and y is representing the height, what's this slope of 1/2 actually telling us? So remember, the y's are upstairs, the x's are down. So what we really have here is we have 1 centimeter, because that's the y's, 2 days. So we should be able to say then, the height of the plant is increasing, it's growing, as you could say growing to, at a rate of, height of the plant is increasing at a rate of 1 centimeter every 2 days. So the height of the plant is increasing at a rate of 1 centimeter every 2 days. If you wanted to change that and even simplify it more, you could say, you know what, this plant is growing at a 0.5 centimeter every day. But if we leave it just like it is as the slope says, this would be a good way to tell what the slope is representing. Okay, this will, along with your SQ3R that you did for today and what we just went through together, hopefully you're set up for being successful with the homework. See you tomorrow.